Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. In last section, we had detailed the plane beam. So we had a plane beam of 450 by 230 m diameter in both. So we had on the top we had 312 through bar and 212 extra. On the bottom we had 312 through bars. So if you look at our foundation model, we'll first detail this pedestal. These were P3 pedestals. So the reinforcement required was you see for P3 was 3255 mm square and P2 was 30, so 3064 mm square. So we have kept same reinforcement both for P2 and P3, and we'll as of now because 3217 minus 3255 is just 38 mm square. So we'll just check with respect to requirement of IS 13920 because at that time we may have to increase the number of bar here. So if you see in the plan, so these are our P3 pedestal. On the side. Now let us go to the sheet of column design as per IS 13920. This is the sheet we have prepared as for pedestal detailing as per IS 13920. Now what does it say? So one of the clause in IS 13920 says that sum of the moment of resistance of column should be 1.4 times sum of the moment of resistance of the beam in that particular direction. So as of now we are considering Z direction. This is the direction. So in Z direction we have a steel column above, but it is released in along the Z direction. So steel column will not contribute any moment of resistance to be added for calculating the summation of moment of resistance of the column. So pedestal alone will contribute the moment required, has to contribute the required moment of resistance. So now what is our size? The size provided for P3 was 525 by 775. So along X direction it is 525, along Z direction it is 770. So along X direction it is 775 and along Z direction it is 525. So now we have to see the minimum factored axial load on the column, maximum factored axial load on the column. So for that we have to go to the start file again. Let us go to mode post processing. Select this pedestal, report, beam and forces, axial. So maximum axial force is 322 kilonewton, and we can know from the reaction itself which load combination will provide minimum support reaction, that will provide minimum axial force. So force Y, list from loading. We have to take the limit state cases, strength cases. So 322 is the maximum and 51 is minimum reaction. So maximum axial load on the column is 322 kilonewton and minimum axial load is 52 kilonewton. So let us go back to the Excel sheet. 322 and minimum is 52 kilonewton. So we have provided dia bar, 16 dia bar. So there is, and there are all are 16 dia bars. So there are 16 numbers of 8 dia bars. Or a closed link, that is the link. If you see here, it is saying whether this link exceeds 300 mm. Wherever it exceeds, the total length exceeds 300 mm, then we have to provide a stirrup to break this length. So it is yes. Cover to the dimension 40 mm. Area of the steel provided is 3217. Now how many legs we have provided? Let us see. Number of leg in x direction. So 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 legs in both the directions. So you have in both the direction there are 5 legs of the stirrups. As of now, we are taking spacing of 175 mm as the spacing of the link non-confined zone, and spacing of the link 100 mm. If mm as the spacing of the link in confined zone. Now you have to provide these reactions from a STAAD for the lateral load cases. So lateral load seismic cases. So IS 13920 is the requirement for seismic detailing. So let us go to the STAAD file and take one of the columns which is having maximum reinforcement. All of them has 3 same requirement. So we take one of the column, report, here we can know the whether it is compressive force or tensile force from the support reaction itself. But in case we do not know what, in case it is a column in upper floor, then we have to go for report generation of section forces. So suppose I take section forces, axial force, so 200 on 200, 203 and 204. So you can see we can consider section process at 1, then again 1, then again 1, then again 1. Copy and paste it to some, add some Excel. So we can know it from here itself, whether it is compressive force or is it tensile force. So but here we have a support. So we'll just take the required load combination report, support reaction, loading. We'll take 2001, 1.5, 1.5, 1.5 points. We are skipping the point load factor with 0.6. So 1.2, 1.2, 1.2, 1. These are our seismic load combination. So copy, then let us paste it here. So we got it. So now one by one I have provided all the requirement of IS 139 minimum axial compressive force. The code says the column strength has to be, moment of resistance of the column has to be checked with respect to the all load combinations. That is why I have taken all the seismic load combination for a column. Now we have to check if the moment of resistance of the column is okay or not. Now we are concerned with the moment of resistance of the column beams with respect to the z direction. So let us go to the moment of resistance of the beam in z direction. So this is our z directions. So we have this plus this 149.6, and this also we should change, although it is not required here. So column is direction 58.5 plus 93.8. There are some mistake in the Excel linking. So in both the directions, the moment of resistance of the beam, summation of the moment of resistance beam is same, because we have provided same reinforcement in the Excel sheet. Same reinforcement is there, but in practical there is no beam in X direction. So this is the direction we are not concerned about. So we have the wall axial load from all the load combination. That is the requirement of the code. The moment of resistance of the pedestal or the column in question has to be checked for all load combination, whether it is 1.4 times the summation of moment of resistance of beam. Now using these forces, we can use SP16 to check whether the moment of resistance is adequate or not. Now that's a time consuming process. I have developed a shortcut process. See, this is the STAAD file input codes that has been prepared, taking axial forces from this, and the moment of resistance required has been given. So we take this, copy this STAAD file, and make a new file called pedestal check. Next, finish. Now we have a STAAD file here. Now let us paste it here in the input editor, whatever we had copied. So the sizes is already taken, so let us close it. Now we have this column, the loads has been given, already given. Now let us check the loads. All the seismic combinations has been taken here. So we have given a analysis. Now let us check the reinforcement. So required reinforcement is 2116 as per the requirement of code requirement. So we do not have to increase the reinforcement here. The reinforcement for this beam we have provided for P3 we had provided 3217. The required was 3255. Now someone might question this why the reinforcement is less. So in that case we can provide 416 420 bar plus 1216 bar. So what will be our reinforcement then? 4 into 314 plus 12 into 200. So this is 3656, which is more than 3255 what was given in the start as per IS 456. Now see, in a PV building the pedestal sizes are usually large because we have to accommodate the steel column. So that is why the required reinforcement is not increasing. But in a RCC, typical RCC column, this reinforcement would actually increase, and we have to provide the reinforcement according to that. So in PV building our pedestal sizes are usually more, so many of the times we do not need to provide extra reinforcement. So now let us go back to our sheet of column reinforcement. So this reinforcement is okay. We have checked it from start. If you want, we can check it with respect to the space section, but reading values from space section is a tedious job. Now you have to see the required link spacing as per IS 13920. So in along X direction we are not concerned for this beam. So along Z directions the moment of resistance is, we have to link it. Number of leg is 5. The moment of resistance sway left from beam in Z direction, sway left is 58.5, sway right is 93.8. So from the right beam is 90, sway right it will be just opposite of that. Now these are the checks as per Codal formula. So for 8 mm spacing we have to provide a 96 mm bar. So if you want, we can actually increase the dia of the bar, link bar. So dia of the ties, if you increase it to 10, then let's see what happens. It still remains same. So this is the part which is governing the spacing of the confinement shall not be more than 6 times diameter, the smallest bar. 6 into 16 is 96 mm. So we cannot provide more than 96 mm. So these are all linked here. For other part, if lab is provided balance part 175 mm center to center, we can provide, but we have to see from the start if the ties are at same spacing as per requirement of IS 456 also. So this is non-confinement zone. The reinforcement check for non-confinement zone. So we can provide 96 mm center to center spacing for confined zone, and for non-confinement zone we can provide ties at 175 mm center to center. Now see, this is the adjacent column, so we are not concerned about the x direction, but for the corner columns we will have both the directions, and on of this movement will be 0. So we have to check with respect to both the directions when their two beams are connecting orthogonal to each other at the column. So with this, our detailing of pedestal as per IS 13920 is complete. So in next class, in next session, we shall discuss about design of footing. So I would request to go through IS 13920 to have a better clear insight to the design requirement of the beam and columns as per IS 13920. You should read that code and compare this Excel sheet with that code, so you will have a better insight. Thank you.